Let us look at one advanced MCQ before you move on to solving the advanced MCQ section. So I'll just explain you the setup. There is a triangular prism here. This is a big vessel. Okay. Now we are filling water in this vessel. Okay. We are filling water in this vessel, and the question asked is, at what height does this triangle raise up? Okay. So at what height of the water does this triangle raise up? That is the question. So let us move forward. Okay. So let us just understand this further. What is happening is the water is rising up. Okay. And because water is rising up, there is a force is acting in which direction? Force acts in this direction, perpendicular to area. This force has an upward component and the horizontal component and the vertical component. This vertical component pushes it up. This horizontal component pushes it towards the wall. Now there is also friction between this and this wall. Suppose there was no friction. What will happen? As this is pushing it up, when this force becomes equal to the weight of this will be pushed up. But there is also friction here. So as this keeps increasing, there is weight and it also has to overcome the friction. So once this upward component overcomes both weight and friction, then only it will raise up. Okay. Let us just mark these things here. This is vertical component. This is the horizontal component. This is the weight, which is mg. Okay. This is the friction, like it is trying to go up, so friction acts in the downward direction. This is the normal reaction. I'll just say it again. Initially weight and there is a normal reaction here acting up. As this force keeps increasing, okay, at one point what happens is this balances the weight. As this increases further, then the friction starts acting and goes on increasing. So that sequence is very important. What happens initially? Initially weight and normal reaction balance. Slowly as water is coming up, this component goes on increasing, and because this component increases, see the height is increasing, so horizontal also will keep increasing, so friction is also increasing, so multiple things happening here. Okay, so let us say at some height h, this starts moving up, so which means the upward force must be greater than the downward force, or just equal to limiting case. F vertical minus mg minus friction equal to 0. Okay. Now what is this friction? Friction is mu into n. What is the normal reaction? Is nothing but equal to Fh, because this is in equilibrium in the horizontal direction. So I can write this as Fv minus mg minus this friction is nothing but mu into normal, which is nothing but Fh, equal to 0. This angle will be theta. Now which is easier to calculate? Tell me, F vertical or F horizontal? See, the horizontal force applied by this on the prism is same as a horizontal force applied by this whole thing on this. Okay, the horizontal force is very easy to calculate. Directly we can do average pressure into area, right? So horizontal is easy to calculate, so we can write this F vertical as, I'll write here, tan theta F vertical by F horizontal. So F vertical is nothing but F horizontal tan theta. So this is 1 and this is 2. Fh tan theta minus mg minus mu Fh equal to 0. Okay. Now I'll take out this Fh tan theta minus mu equal to mg. Okay, what is FH? Average pressure into area. So average pressure here is 0, here it is rho gh. So average pressure is rho gh. This h we need to calculate by 2 into what is the area of this? Area is nothing but width of the tank is b. So b into h is the area into tan theta minus mu equal to mg. Okay, so I can just write this as rho g b h square by 2 equal to mg by tan theta minus mu. Okay, now I can cancel out this g here and directly I can get h. So what is this h? Must be equal to 2m divided by rho b into tan theta minus mu. Okay, as a square, so I'll just have to put a root here. And this is the height at which this just escapes from it. Okay,